All right, let's dive into something, well, something really cool. Today, we're talking about Arduino Vision. We're going to explore how simple pixels from a camera are being turned into actual physical prototypes that you can touch and interact with. So, I want you to just think about this for a second. Seriously, what if your computer, the screen you're staring at right now, wasn't just, a dumb monitor? What if it was actively watching you and actually understanding what it was seeing? And let's push that idea even further. What if it could take what it sees, your smile, a wave of your hand, and use that information to control things, actual objects in the real world? I know, it sounds like something straight out of a sci-fi movie, but this is happening right now. And that's really what this is all about. We're talking about going from pixels, these tiny dots of light on a screen, to physical action. It's about bridging that massive gap that's always existed between the world of software and the world of hardware. But that brings up a huge challenge, right? I like to call it the digital-physical divide. Just think about it. How do these incredibly powerful software brains, the kind that run complex AI, how do they talk to simple hardware bodies that really only know how to do basic things like spin a motor or turn on a light? I mean, these are two totally different worlds. On one side, you have the digital world, the brain. It's all about complex logic, deep learning, processing tons of image data. And on the other side, you have the physical world, the body. It's all about simple actions. Turn this motor, light up this LED. They just don't speak the same language. So how in the world do you get them to talk to each other? Well, it turns out you assemble a kind of dream team, a team of three key technologies that work together to translate what the computer sees into real physical action. First up on the team, you need the eyes. In this case, that's MediaPipe. It's this incredible deep learning tool from Google. Its job is to look through a webcam and not just see a person, but to understand them by tracking all these key points. They're called landmarks on your face and body, and it does it all in real time. Okay, so you've got the eyes. Next, you need a nervous system. This is a Python library called PySerial. Think of it as the messenger, the crucial translator that takes the smart decisions made by the Python brain and dumbs them down into really simple signals that the hardware can actually understand. And finally, you need the hands. This is the Arduino, a super simple microcontroller. It gets those simple commands from the nervous system, and it just acts. It physically moves a motor, it changes the text on a display, it turns on a light. This is where the digital stuff becomes real. Okay, so we've got our team. The eyes, the nervous system, and the hands. Let's see them in action. For our first project, we're going to translate a simple smile into a message on a physical screen. You see, this whole thing works by basically boiling down a human emotion into raw data. The source material puts it perfectly. When you smile, it's not just a feeling, it's a measurable increase in a numerical value. And when you're sad, that number goes down. So here's how that data flows. It's a 5-step process. First, the webcam sees your face. Easy enough. Second, MediaPipe, our eyes, zeroes in on the landmarks right at the corners of your lips. Third, the Python brain calculates the distance between those 2 points. The wider the distance, the bigger your smile, right? Fourth, based on that number, Python sends a really simple character, like the letter A, through our nervous system, PySerial. And finally, fifth, the Arduino hands get that A and act, updating a physical screen to say smiling. It's that simple. Okay, a message on a screen is one thing. That's pretty cool. But what about controlling actual physical movement? Let's level up and see how these same principles can control a robotic arm. This time, instead of looking at your face, the system is tracking the position of your wrist and your shoulder. The distance between those 2 points on your own arm is what's going to control a physical motor. And the logic is super straightforward. If the distance between your wrist and shoulder is small, you're holding your arm in, the system sends an A signal and the motor moves to 45 degrees. A medium distance sends a B for 90 degrees. And if you stretch your arm all the way out, it sends a C, and the arm opens all the way to 180 degrees. So your continuous movement gets translated into 3 distinct physical actions. Look, these projects are awesome, right? But the real story here is much bigger than just a smiling screen or a robotic arm. This is about what this technology means for all of us. It's about a maker revolution. There's this fantastic quote from the source: "There's no limit to what we can do in the software world." And for so long, that limitless potential was kind of trapped behind our screens. But now, because of tools like these, all that creativity is breaking out into the physical world. So what's the big takeaway here? What should you remember? Well, first, that this advanced stuff, AI and computer vision, it's not just for big tech companies anymore. These are DIY tools for you. Second, that bridging that gap between digital and physical is easier than it has ever been. It means you can build and test really complex ideas with pretty simple hardware. And finally, maybe the coolest part, your own body, your gestures and expressions can become a brand new way to interact with technology, a new user interface. Which leaves us with one final, and I think very exciting question. Now that you know the tools are out there to make your computer see you and react to you in the physical world, what will you build?